Hi, I'm Kevin Drinkall.
Hi, and I'm Michel Nicolai, and we welcome you to Zyxel Networks podcast.
We've been in the network industry for over 15 years, and in these podcasts we want to try and untangle the world of networking, debunk some of those myths, explain some real-world examples along the way, to help you make better choices about selecting the right tech, product, and even help you guys build faster, more reliable, scalable networks, or just to keep your kids happy at home.
In today's podcast, we try to explain more about Wi-Fi, their frequencies, of course their standards, and also the antennas that we're using in our access point.
So not a small topic and quite complicated. So let's try and keep it light and very top level and try and bring some revelations, I guess, to Wi-Fi itself, right? So I guess we should start with the building blocks of Wi-Fi and really talk about how it all comes together. So we build this picture so you understand how Wi-Fi works from a top level point of view. And some of you may be familiar with how Wi-Fi works, but maybe there's little bits of information missing or you've never really quite thought about it in different ways. So we'll start with the frequency side of things. So wireless operates in 3 different frequencies today. Before that, it was predominantly 2. And this is 2.4 gigahertz and 5 gigahertz. And now we extend into 6 gigahertz. And we'll talk a little bit more about that in a minute. So I think 2.4 gigahertz, it kind of has a pros and cons. And I don't want to go too much into detail on that. But basically 2.4 for a long time was the dominant frequency because it had the distance. It could cover more area, and people at the beginning, in the early days of wireless, really just need the coverage. They weren't so bothered about, the density, which is how many devices we're connecting. So when we refer to density, we refer to lots and lots of devices. And in the early days, I remember both of us, right? We used to do the presentations about Wi-Fi, and we used to talk about when you went into a hotel room, a guest would only bring 1 or maybe 2 devices, and people, when they were doing specs for hotels, they would be putting 1 in the corridor and hoping to cover a wider area, right? So
coverage is key, and the number of clients that we need to support is getting more and more, so we need to prepare for this. And the 2.4 is good for the engagement and get connected to the Wi-Fi. But the 5 gigahertz gives us much more opportunities because we get more channels where we can choose from. Because, the more APs we put on, it's getting more and more difficult to find a unique channel where we can send our Wi-Fi on. Yeah. So that's really the case. So 2.4, we had 3 channels that were non-overlapping, and that was not enough for a proper deployment. So therefore, the 5 gigahertz, suddenly we had 19 channels. And that gives us a really good opportunity.
Absolutely, yeah. So if we just take a step back so people understand. So in 2.4, you theoretically had 13 channels, right? Or 12 channels in Europe. And the problem with this is that they overlap with each other. So basically you end up with 3 channels that you can use. Now, this is okay when you've got 1 access point and there's no interference from anyone else. But when you start deploying multiple access points, you start to come across the channel management issue of 3, right? And then obviously we went into the next kind of standard, and we started to use 5 gigahertz, and we had much more channels clean because every single one didn't overlap, and it meant that we had more basically roads to carry data down, right? So it expanded the horizon massively in terms of bandwidth, which was available, and availability for density, right? So
and therefore, because the traffic has become more and more and more, and then what happened on the motorway? If you get traffic jams, what are you going to do? You want to provide more lanes, for more traffic to carry. So and they brought that solution, just to expand your channel width from 20 to 40 megahertz. So we provided an extra lane for people to use. Therefore, we increased the speed also, for this matter. There was only one negative side on it, because when we doubled the channel width, the number of channels we could use effectively in the 5 gigahertz was reduced from 19 to only 9. So it's been a major drop down, but still we have a lot of channels we can use, for our deployment.
Yeah, so basically, in a nutshell, right, when we wanted to go faster and faster, we just kept teaming the motorway lanes together, right? So it made it, so where there was 2, we now only got 1, but it's twice as wide. But then no one else can use that channel. And then eventually we did the same again, right, where we basically took 4 channels and banged them all together, and then we make one big wide channel, right? So, and effectively this is how we can kind of create the speed, etc. So to give some real world kind of examples of the speeds that was achievable, right? So back in the day of Wi-Fi 4, where 802.11n standard, I don't want to go all the way back to the very beginning, right? The maximum theoretical speed, there was a kind of standard in the middle, which was a bit dubious, but it was 600 megabits per second, right? And then the way that they kind of measure it is by using spatial streams. And at the beginning, you needed to kind of match the spatial streams with the device and the access point to get the maximum speed. There are some different technologies in different vendors to kind of maximize that. But the reality is, if you had a 2x2 access point and you had a 2x2 device, then you would be able to achieve, in the end standard, at least 108 megabits per second. And then obviously there's 2x2, there's 3x3, there's 4x4. Theoretically, you could go to 8x8 in some standards, right? When they brought in Wi-Fi 5, which was 802.11ac, which is the IEEE standard name for it, this allowed the maximum theoretical speed to be 6.9 gigabits per second, more or less. Under the same channel widths, which Michelle just mentioned, you could achieve like 866 megabits per second under a 2x2. So a lot of devices at the early days were 2x2s, which meant when you connect it, you would physically see 866 megabits per second connected, right? And again, under the 4x4 channel, you could achieve sort of 1.7 gigabits per second. So some seriously advanced speeds from Wi-Fi 4 to Wi-Fi 5. And then we went from AC or Wi-Fi 5 to Wi-Fi 6, which is kind of today is the kind of standard. And that gave us a maximum theoretical speed of 9.6 gigabits per second. It was kind of deemed the first standard that could get to 10 gig. I mean, not quite, but theoretically it could.
Yeah, and you see that every time we doubled our channel width. So with the N standard, it was a 40 megahertz channel, like the Wi-Fi 4 standard. Then we moved up to 80 megahertz in the 5 standard. And now, as Kevin said, that on the AX, we now provide 160 megahertz. So we doubled again to provide the highest capacity that we have today.
Yeah, so in a real world, if you connect it a 2x2 in Wi-Fi 6, you theoretically can actually get past the 1 gig network barrier, right? So theoretically, there's a 1.2 gigabits per second throughput if you measured on a single device, for example, in a lab environment. So, but this is, it's an advancement. And again, if you actually had a 4x4 in AX, you could also achieve 2.4 gigabits per second as well, right? Especially when you're using kind of 80 megahertz channels, right? And that's how it's broken down is 20, 40, 80.
Yeah, but there's one counter side, on this. Because it's nice to increase the speed every time, but the counter side is that the number of channels that we can use is reduced every time. So, as I said earlier, we had 19 channels in the 20 megahertz. At the moment, the most common standard we're using is AX. We only have 2 channels left to choose from when we select the 160 megahertz.
Yeah.
So that's really a challenge,
And these also, that includes with the DFS, right? So for those people not familiar with DFS, there's a part of the frequency that's kind of designated that you can't use when you start up. And basically what it does is when it boots the wireless up, it has to sit and wait to check if something else is using that part of the frequency. It's typically something called like a Doppler radar or something like that, is bound by that part of the frequency. And the device has to wait. So lots of APs actually don't want to use that because they have to sit and wait for that channel to be checked. And that means the startup time for a wireless access point can be longer.
Yeah, well, maybe you can also give an answer to the question: what is the influence of the reduced number of channels that we can use in Wi-Fi deployment? Why is that important? Maybe that's something that we explain to the audience.
So I think when you are doing deployments, I mean, you never really want to use the really, really wide channels because you're prone to interference, right? Because like you say, there isn't many channels left. And when in the Wi-Fi standard, if communication, hits a Wi-Fi, either if it's in the same channel, Wi-Fi is basically told to almost just basically need to wait, so it just stops communicating. And the result in the real world is that you end up with dropouts, you end up with fluctuating traffic, and you end up with the call dropping or buffering or all these types of things, right? So it doesn't really do very good it doesn't really create a good Wi-Fi environment to work in. So it becomes quite challenging. So especially when you are, if you've got lots of density, your tendency is to put more access points in to cover it. But more access points means they're using more channels, right? So, and they can't be on the same channel. So the idea is that, when they're roaming from one AP to another, the client, that's actually moving from one channel to another channel. So you have to have proper channel management, etc., in place. And that means not being on the same channel. So using massively wide channels really creates a big problem.
Yeah, you mentioned roaming, and that's a very key element, what everyone likes to see when they're building a Wi-Fi deployment. And yeah, what do you really need for roaming? Yeah, because people say, oh, does your AP support roaming? And yeah, it's not only AP related. Yeah, it's much more than AP related.
Absolutely.
Because the Wi-Fi name should be the same on all your access points. The way you encrypt, so the password needs to be the same. Yeah, the subnet where you're entering after your verification to the network needs to be the same. Of course, we need more than 2 APs, because if there are not more APs, there is no roaming. And last but not least, we need some overlap.
Exactly.
Because otherwise we have a black hole, where we're sitting in. And of course, if we don't have coverage, no coverage is no roaming.
I mean, people ask for, like the roaming standard 802.11.r, right? Which is the ability to roam. And to really do roaming correctly, you should be using WPA2 Enterprise, which is a kind of standard in the encryption, right? And that means that the APs can kind of offload and talk. Now, there are other ways around that, and there are other roaming protocols, etc., that things like Apple and Android devices support as well to do that roaming. But I think when you're doing the deployment and you are really thinking about how to deploy, there are some considerations to make, right? So one is the channel width is quite an important part, if we go back to that part, because this bit is we need to create a good overlap with different channels. And if you can keep the channels narrow, then that means then you can roam quite aggressively from one AP to another, and you can create very good experience. But the side effect is that you create slower speeds. So it really depends on what you're trying to achieve with the client device. Then the next thing is the coverage. So, I mean, do we need to ramp up the power full on all these APs to create that? Maybe not. It depends on your environment. And also the frequencies that are going to be used, right? So when we go back to the standards, like Wi-Fi 5, the 802.11ac, this created massive improvements over the older generation by introducing 5 gigahertz to be the main driver, right? Then we moved to AX, which is Wi-Fi 6. And when we did this, we actually created 40% better data rates, 4 times the capacity or performance. We allowed it to go back to doing dual band, so 2.4 and 5 gig. And like I said before, theoretically, it does 10 gig or 9.6 gigabits per second, right? So some massive improvements in terms of speed and deliverable, right? And basically, when you move from AC to AX, you generated a much cleaner way to work in Wi-Fi. There are some other technical features as well, of course, but the idea is not to get bogged down in those, right?
Yeah, maybe we're talking about speed, channel width, and those kind of things, but also the design of the product that we built within Zeisel, the number of antennas that we're using, the quality of the build of our AP is also very important to have a successful Wi-Fi experience. So talking about antennas, yeah, you see that the sensitivity of our product is generally much higher than other manufacturers. Have you seen that as well?
This is something that I think, so those who don't know how the kind of Wi-Fi is kind of measured, it's measured in dBm, right? So, and the important factor about Wi-Fi is it's a two-way communication, right? You can't have one person shouting and the other person whispering. And when I use this example, I mean, you can't have the access point shouting, then having to listen for whispering, right? So, and it's a fact, right, that, a mobile device just simply doesn't have the power. It has to find a power to battery ratio to, output for Wi-Fi, right? So it's important to have devices that can really clearly try and listen in the airwave to create that better quality. So when we build APs, we shield the components, we tweak the antenna design, and actually we do have some specific antenna designs as well that help in different scenarios. And I think we should cover those in this podcast, but let's just talk about the kind of listening part first, right? When you shield components inside the access point and you really spend the time in the engineering resource to kind of tweak that, you can maybe improve 1 or 2 or maybe even 3 dBm in the air, right? And this could be the difference between connecting speeds of 300 and 400 to 800 and 900 megabits per second. It can make that much difference, right?
Yeah, because you need to imagine, 3 dBm is make sure that your signal is dropping 50%, 50%. That's huge, yeah. So any dBm that you can keep is crucial.
Yeah.
So we talked about the quality, the shielding, the sensitivity, but of course the number of antennas is also important. The more we have, the more we can receive, and therefore you see that some of our devices don't have the standard 2x2, but even 4x4. So that is also giving you a big benefit of listening to, let's say, smaller devices that are not that powerful.
Yeah, of course. Wi-Fi doesn't travel in a straight line, right? It bounces off the walls.
Yeah, 100%.
And off the all different objects, and then the access point receives it from all different angles, and then puts all that information back together. And by listening on so many more antennas, like I said at the beginning, there's a technology element as well, right? A beginning 2x2 on one and a 2x2 on a client device and an AP kind of had to match, but then eventually technology made it so that we could listen in different ones and then reallocate. The processing power of access points is, massively improved, right? So it's able to do this at much a higher rate. And that's why we now have these super fast speeds that you get on the access point. But then we have the antenna design itself, I guess, right? Because antennas are typically designed to be ceiling mounted. This provides, a lot of obstacles in some scenarios. For example, you've got warehouses.
Yeah, when you have the ceiling up to 20 meters high.
Yeah, exactly. Yeah. You lose half the signal by the time you've got to the top, right?
Yeah, it's incredible.
And then, if you put an access point on the wall, so by default, an access point's kind of got like a semicircle of radio pattern, right? It's not very easy to do without actually displaying it, right? But if you turn it on its side, it's just going to pump, the signal into the floor above, or the ceiling and the floor, right, if you put it on its side. So if you put an AP on the wall, which in some scenarios you just can't get away with, right, this creates some problems. So we do have some technologies.
Yeah, Zeisel has a great feature for that. It's called dual optimized antenna. Mm-hmm. In the original design, it was a physical switch on the AP, and now it's a soft switch that you can manage through the software to enable or disable this, but it gives you great opportunities also for you, maybe as a reseller, that you can have one device on stock that can be in multi scenarios be installed, because you have the opportunity to put it on the ceiling, or the same product you can also install on the wall. So that gives you a lot of flexibility with such kind of product. And yeah, and Zyxel is quite unique in such kind of development.
So that's pretty amazing that you can kind of have this AP that changes its, its antenna pattern based on the kind of installation environment, right? So where you put it on the wall, or that's pretty cool. The other type of technology that we have in some of our flagship products is the smart antenna. And I don't want to go into too much of the kind of technology behind it, but the technology behind the smart antenna allows you to create the best or optimal conditions in a tough environment. And when I mean tough environment, I mean it could be density, or it could be, challenging by interference. And often when we're doing these installations, or we're advising customers to, put APs in, and they come to us with this kind of environment, we basically say, if it doesn't work with a smart antenna, then it's just not going to work at all. So when we talk about this, we really should maybe talk about the kind of environments, I guess.
Yeah. I think, you can name a lot of difficult or challenging environments. For instance, look at warehouses where normally, typically, if you put the AP on the ceiling, it won't work, especially because the ceilings are often 20 meters high or something. Then what is challenging is that people are using scanners, maybe not with the latest technology, and you need some compatibility and good connection to your AP. So those are rough environments where you see that smart antenna can help you a lot. Hospitality is another one.
Yeah, exactly. I mean, one of the things I would say about a smart antenna is you've got the height, you've got the fact that you can put it on the wall or a ceiling, or even in some cases underneath or behind objects, and the antenna will try to adapt to that environment. The other thing is the kind of materials, like in warehouses and even in some hospitality environments, there are challenging environments with the walls, etc. And this is the maximum you would kind of gain from that product. Also, like in hospitality, you've got the density, you've got a mix of older and newer generation devices, and whilst new technology advances, you've still got to cater for those old devices or previous generation devices. And smart antenna kind of gives us the best of all of those kind of things without any kind of extra stuff.
Yeah, and smart antenna, it's working independent from your Wi-Fi standard. So it doesn't matter if you're using AX or AC or any kind of Wi-Fi standard, you always benefit from your smart antenna functionality. And that's a real good thing that you have on hand on those devices.
So when we're talking about challenging environments, we have the kind of smart antenna series, which in the kind of models from Zyxel, right, they end with an S on them, right? So we have the 630S, the 640S, and the 650S, right? So depending on your kind of environment, and the 650S, which is our flagship, I mean, it even achieves some ridiculous speed, right? So
yeah, 4 or 5 gigs in that area. It's unbelievable, yeah. So it's really our flagship product. Still, it's 2.4 and 5 only, but we definitely also support the 6 gigahertz, not on the 640, on the 50, but on the 640, because that's our first triple radio AP that has all the frequencies and has the benefit of smart antenna as well.
So when we talk about 6E versus 6, then where would you use the 6E over 6? Density? It would probably be density, right? So
yeah, but also think about if you want to use mesh, you can have some kind of 6 gigahertz backhaul that you can use that one. Then you have a very clear, very fast backhaul that can talk between the access points. So that's also a very nice opportunity that you have when using the 6E as well.
So, I mean, so we've kind of figured out, okay, challenging environments, the the kind of what 6E and 6 will give us. So, in the other Access series range, I mean, let's talk about some of the scenarios where you'd use different models, right? So, let's go down backwards, right? So we talk about the 6000 series in our Access Plus range and where they sit. So then what next, right? We have this optimized antenna.
Yeah, with the 510 and the 610, those devices, they have the dual optimized. For people that don't know, the 510 is a 2x2 on the both radios, and the 610 will leverage from the 4x4 on the 5 gigahertz as well. So it gives you extra performance on that radio. And also on the uplink, we do the extra mile, since we see that other manufacturers are only providing a 1 gig uplink. Yeah, Zyxel is providing a 2.5 multi-gig uplink. So you can really get your speed into your network. So also for dual optimized, we have our APs available. Yeah, definitely.
Excellent. So, and then, when we're sort of talking a bit further down there, we have the NWA 110, 210, which I would say if you're just starting out with business installs, then this is the kind of AP you kind of want to
that's the AP you want to go for. Yeah, that is the generic AP you can start with. Yeah, and then if you need specific requirements because you want to leverage from wall mount or leverage from the smart antenna, then you can always go in that direction. But yeah, the NWA 110 and 210 are the right products for you to start with the AX product that gives you the benefit. Yeah, definitely.
And then, so right at the very, very, very sort of beginning of the portfolio, we have the 50AX and 90X, which, I mean, predominantly is for kind of a prosumer, a small office environment. So when you look at our kind of portfolio from end to end, you kind of build up from in terms of size or kind of the challenges that you might have in your environment. So, you have a small business or you're a prosumer kind of, looking for that kind of business grade AP for home, then this is kind of where you would stay, and you would leverage from that AX technology, the benefits and the speed. And then as you go into kind of a business environment, you would go into the 110, 210, leverage from some of the multi-gig technology, some the benefits there from a business grade AP. And then you would move into, I would say, a bigger environment, right? So small to medium business kind of delivery or a vertical like education where you might need a mix of smart antenna and standard APs in an environment, then this is the kind of way that you would go. So you could use the 5000 series and the 6000 series. And I think when you look at the portfolio in this way, it makes a little bit more sense. And I know often we get a lot of questions, right, about which AP
100%.
does what.
Yeah, sure. Yeah, and especially on the edges. Yeah. So when do we do NWA 90AX? When do we 110? Yeah, and then when we move to the next one, that's always those are always challenges. Yeah. But what we can say from NWA 110 and upwards, you are always working with a premium Wi-Fi chipset, that is built for businesses with multiple connections.
Yeah.
So that's really the solution that we want to advise to use. But in some cases, if you're looking for a more cost-effective solution, then we have that also in place with our 50 and 90.
Wow. So we crammed quite a bit in this podcast, right? We managed to get a little overview of some of the technologies, the frequencies, some of the generic stuff in Wi-Fi, and even the portfolio.
Incredible. Yeah. But what's next? Do you know what's next?
So, the future. I mean, I guess we could talk about Wi-Fi 7, right?
Yeah, definitely. Because Wi-Fi 7 gives us big opportunities. Yeah, not only higher speeds, but also it will reduce the number of roaming issues. Because, we now are not connecting to a single channel. Now we can leverage from all the channels, so connecting 2.4, 5, and 6 simultaneously. So opportunities are huge on this. Yeah.
So, I mean, just let's throw some out there for the audience, right? So, 46 gigabits per second, that's the theoretical top speed of Wi-Fi 7. We have double the channel width, right? I mean, I would never use them in business, but you have some practical applications for backhaul for at least, right? So, 320 megahertz wide channels. We're going to be using, like you say, all three channels at the same time, so we can pick bits of channel from each frequency and utilize it at the same time. So inevitably creating lower latency, more capacity. And then there's a lot of other elements to it, but I think the multi-AP coordination is quite interesting for me. I think where multiple APs will be able to talk to a single client at once. I mean, like you say, roaming in this instance, I mean, it won't be roaming anymore, right? It'll be connected to several different...
Yeah, it's really incredible. Of course, you can question, do we really need the speed? Yeah, maybe not a single user. If you have multiple connections, with a lot of people connecting to a single AP, it's no problem. Capacity is not an issue anymore. It's really a standard that provides us really good features for that we can use in the near future. Have you any estimate when we will launch such a product?
So, I mean, we have Wi-Fi 7 in development, right? So I would say it's not very far away. So I think we definitely be seeing, I mean, it will be here in 2024, right? And maybe even might start seeing some vendors and even ourselves seeing some prototypes towards the end of 2023. I mean, but why should people wait for Wi-Fi 7 or should they use 6E? I mean, 6E has a lot of benefits still, right? I mean, for those people who are doing upgrades now, Wi-Fi 7 is not really matured yet, right? So, and the clients aren't there, so 6E gives us the benefits of the loads more channels.
Yeah, I fully agree. Before every vendor is ready to adopt the Wi-Fi 7, I still think there's room for the Wi-Fi 6E, and
Well, that brings us to an end of this podcast.
So thank you for joining, and hopefully don't forget to subscribe to our podcast.
Absolutely.
So that the next one will pop up automatically in your application. So that will be really nice.